I'm Brian DeLuca, and today we're going to talk a little bit about how electric motors work. Electric motors are a part of our daily lives. They power everything from household appliances to industrial machinery, revolutionizing the way we live and work. Understanding how these marvels of engineering function is key to appreciating their significance in our modern world. We're going to explore the fundamental principles behind electric motors, their components, and their applications. The basics: electromagnetic induction. At the heart of every electric motor lies the principle of electromagnetic induction. This is a phenomenon discovered by Michael Faraday in the early 19th century that states a changing magnetic field induces an electric current in a conductor. In an electric motor, this concept is applied by creating a rotating magnetic field. When the current flows through a wire wound around an iron, it generates a magnetic field. By carefully arranging multiple coils and controlling the flow of current through them, engineers can create a rotating magnetic field. This field interacts with the permanent magnets or other coils, leading to the motion of the motor's rotor. Components of an electric motor. The stator is the stationary part of the motor and contains the coils of wires. When energized, these coils produce a magnetic field. Number 2, rotor. The rotor is the moving part of the motor. It contains conductive elements that interact with the stator's magnetic field, causing the rotor to turn. Number 3, the commutator in DC motors. Found in the direct current DC motors, the commutator is a split ring connector to the rotor, which ensures the current direction in the rotor winding changes as the rotor turns. This allows for continuous rotation. Number 4, brushes in DC motors. Brushes are stationary contacts that press against the commutator, transferring electrical current to the rotor. Number 5, bearings. Bearings support the rotor shaft, allowing it to rotate smoothly within the stator. Number 6, permanent magnets. In some designs, permanent magnets are used in place of or in addition to electromagnetics in the stator. These provide a fixed magnetic field that interacts with the rotor field produced by the stator. There are several types of electric motors, each designed for specific applications. Number 1, direct current DC motors. They operate in one direction. They're suitable for applications where precise speed control is required, such as household appliances, small tools, and some vehicles. Number 2, alternating current AC motors. Operate on alternating current, widely used in industries and household appliances due to their efficiency and reliability. Number 3, synchronous motors. Synchronous motors operate at a consistent speed proportional to the frequency and the AC power supply, often used in applications where consistent speed is essential, such as clocks or generators. Number 4, induction motors. They're the most common type of AC motors. They do not rely on brushes or commutators, making them reliable and low maintenance. Number 5, brushless DC motors. A variation of the DC motor without brushes or a commutator. Offers improved efficiency and requires less maintenance. Electric motors play a pivotal role in various industries and applications. Number 1, transportation. They power electric cars, trains, buses, and electric bikes. Industrial machinery. They drive conveyor belts, pumps, compressors, and manufacturing equipment. Number 3, household appliances. They run fans, refrigerators, washing machines, and vacuum cleaners. Renewable energy. They generate electricity in wind turbines and hydroelectric plants. Electronics. They power computer hard drives, cooling fans, and other components. Understanding the principle behind electric motors enables us to appreciate their significance in our technology-driven world. As technology advances, so too will the efficiency, power, and the versatility of the electric motors, continuing to shape the way we live and work. For more on technology and making, make sure you like and follow. Also, check out our newsletter at ghostchickenranch.com.